Hi everyone, this is the final video in the series of differentiation 1 topic, and this video will talk about higher order derivatives and parameterization. So till now we have seen problems of dy by dx, dy by dx, dfx by dx, but we haven't really gone into higher order derivatives. And higher order derivatives mean that you will see things like d square y by dx square, d cube y by dx cube, and things like that. So what do these things mean, and what does this is higher order derivatives, and this is not dy by dx whole square. So please do not get confused in this notation. If it is dy by dx whole square, they will put a bracket and then say square of this. This is d square y by dx square. So what do we mean by something like d square y by dx square? So let me explain you mathematically, and then I will try to give you examples so that you can practice this. So this is d by dx of dy by dx. Okay, so this is d by dx or dy by dx, and d cube by dx, d cube y by dx cube is d by dx of d square y by dx square, which is nothing but d by dx of d by dx of dy by dx. So if you differentiate a function again and again with respect to x, that is called higher order derivatives. So you might recall that dy by dx is actually equal to 1 by dx by dy, and in case you don't know that, it is handy to know this, that dy by dx is equal to 1 by dx by dy. However, you should note, please note that, and do not get confused, because so if you have just differentiated once, then it makes sense dy by dx is equal to 1 by dx by dy, but whenever you have differentiated twice, because you are again differentiating there are two differentiation with respect to x here. This is not the same as 1 by d square x by dy square, because the second differentiation here is with respect to y, and here it is with respect to x. So just so that you remember, this is a side note that I want to talk about this here. Okay, so do not forget this. So let us take examples, very quick examples of remembering what does higher order mean. So let us differentiate sin x. Let us have y is equal to sin x. Okay, so now if you have dy by dx, we know dy by dx is cos x, and d square y by dx square will be differentiating dy by dx. So differentiation of cos x is minus sin x. Similarly, d cube y by dx cube will be differentiation of minus sin x, so that will be minus cos x, and differentiation of d4y by dx4 would be differentiation of minus cos x, which is minus of minus sin x, which is nothing but plus sin x. So to give you an idea, this is how what you would mean by derivatives of higher order derivatives. Let us take one more example, just so that you are able to understand. So if you have 4x cubed power 4, dy by dx would be 4x cube, d square y by dx square 4x cube, it would be derivative of 4x cube would be 12x square, d cube y by dx cube would be derivative of 12x square, so it will be 12 into 2x, which is 24x, and d4y by dx4 would be derivative of 24, which is just constant 24, and so on. And d4y by dx4 in this sense would be 0, d5y by dx5 would be 0, so you can calculate these things. Alright. So this was just a very quick introduction about higher order derivatives. You should know them, and it is pretty straightforward to understand them. So now let us talk about parameterization, and then I will club these two things, parameterization. So if you have a parameter t or some other parameter theta, then it is very easy to sometimes calculate derivatives by this relation. So if you have a dy by dx, then you can calculate it as dy by dt by dx by dt. So basically you differentiate both of them with respect to y and x with respect to t, and then take the ratio. So that will give you a dy by dx. So let us try to solve a problem so that we can mix these two things, like combine these two things and make a problem out of it, a nice problem out of it. So the problem says that, this is the problem, x is equal to a cos t plus log of tan t by 2 y is equal to a sin t. So find d square y by dx square by dx, d square y by dx square at t is equal to pi by 4. Alright, so we have been asked to find second order derivative d square y by dx square at t equal to pi by 4. So now first let us try to just find dx by dt and dy by dt so that we can find dy by dx, right. So the first step for d square y by dx square, to find d square y by dx square, is to find dy by dx. So let us first find dx by dt and dy by dt so that we can find dy by dx. So dx by dt is equal to a of minus sin t plus log of tan t by 2. So we can just use some rule. So cos of derivative cos t is minus sin t. Log of tan t by 2 is log of x type problem. So 1 by tan t by 2, and then derivative of tan t by 2 is sec square t by 2. And if you will actually simplify this expression, you will find that this becomes by half. This will become minus sin t plus 1 by 2 sin t by 2 cos t by 2, which is nothing but sin t, and this will become a into 1 minus sin square t by sin t, which is nothing but a cos square t by sin t. Okay, I hope this makes sense. I have just done it, you can do it yourself. This will become a cos square t by sin t. Now if you want to find dy by dt, that is very straightforward. Dy by dt is a cos t. Now to find dy by dx, what we can do is we can do dx by dy by dt by dx by dt. So we have to divide this by this, and if we do that, we will get a cos t by a cos square t by sin t, and this means this is sin t by cos t, or this is tan t, right. The first relation we get is this. Now next step is to find d square y by dx square. So d square y by dx square, if you have to find that, now in this relation, if I substitute y as dy by dx, then that will give me d square y by dx square. In other words, d square y by dx square is nothing but d of dy by dx by dt by dx by dt, right. So if you want to understand, you can think of these two relations together, right. If you replace in that relation, in the top relation y as dy by dx, you will get this relation. This should be, I hope this is clear. So now if we want to find d square y by dx square, then we have to differentiate dy by dt, so dy by dx with respect to t. So this is d of tan t by dt, because this is dy by dx, and by dx by dt, which we already know is a cos square t by sin t. And if you do that, this will become a tan t derivative is sec square t, so this will become 1 by cos square, and there is already a cos square in the denominator, so this will become sin t by a cos 4t. and then you can evaluate it at t equal to pi by 4 and write the answer for this. So final answer is this. Okay, so you can see slowly how we can calculate higher order derivatives, and then how we can calculate using parameterization we can calculate higher order derivatives. First we will evaluate the first derivative dy by dx, and then we can evaluate d square by dx square. So I want to give you a small practice problem so that you can do higher order derivatives on your own and then also try parameterization. So the homework problem I'll write here. Homework problem is that if x is equal to at cube and y is equal to bd square, find d cube y by dx cube and dx cube by dy cube, sorry, d cube x by dy cube. Okay, and again these things are not the same, these are different from each other. So I hope you enjoyed this video of higher order derivatives and parameterization, and it was useful for differentiation 1. So we have a lot of videos on differentiation 1. Please go through all of them to really understand this chapter. We have covered all the important topics slowly and steadily, and please practice in this chapter. Practice is really important, and in the next chapter we will be talking about the application of derivatives or differentiation 2. I hope you enjoyed the video. Thank you.